Hello again everybody, and welcome back to my playlist, the Locomotion, which I have dedicated to building or rather modifying a toy train set into a model train, a proper one. So as I've told you before in the first part of this playlist, we are going to power the Locomotion, the powerhouse of the train, by not using the battery to install the battery inside there. No, we are going to power the locomotive using this motor governor, or I would like to call it the speed controller, DC motor speed controller, which is the voltage is 5 to 30 volts DC, and the current is 5 ampere with the power of 150 watts. That is the maximum capacity of this motor governor, the ZKMG that I got it from Shopee. So the idea is, as you can see over here, this is the input voltage, plus the positive and the minus the input, and this is the output. So the power, the positive and the negative, will be supplied by one of these DC power adapter, which changes the power from our walls. The standard for Malaysia is 240 volts down to 5 volts, because I got two over here. This one will give the output of 5 volts, while else this one gives out 12 volts. So this is just for a spare, but I guess the most suitable is this 5 volts, because let's open up the locomotive. As you can see, the motor here, this is the size of a motor that even powers the Tamiya racing cars that goes around the track. What do you call that? Tamiya, right? So I guess the maximum voltage that this motor can handle is about 5 volts, as big as the maximum power that comes up from this DC power adapter. So firstly, we are going to connect the cables from the DC power adapter onto this motor governor. But then, as you can see, the ports for this power, the motor governor, is a simple in and out, right? Plus and minus. So we have to cut this head off, and then I'm gonna strip out the rubber, the insulator rubbers, and we're going to just stick the cables directly in there. So cut the heads off, and then as you can see, actually there are two wires binded into one. So what you do is you split it in the middle and you pull them apart, and you will have two cables, which is one of it is a positive and the other one is the negative. So how do you differentiate which is the negative and which is the positive? So I got a background of engineering from the electromechanical engineering course that I took when I was in college years. So as you can see, this part has a stripe on it, white, black, and white, right? So this is the positive. So you strip this part, the insulator, off, so that it will reveal the copper wire inside, and this is the positive side. So this goes there, as you can see, the V plus. So you can see there's a hole in there, so you just push that in, and using a test pen, a minus screwdriver, just tight tighten the screws in there, right? And the other one, which doesn't has any stripes on it, it's a solid black wire. Strip it off, and this is the negative side of the cable. So as mentioned over here, V minus, so this goes there, V minus right there, and then also the same, using a test pen, a minus screwdriver, just tighten the screws in there, so, and have a good pull, so to make sure that the cable is inserted good to that part. So now we are going to plug this in. Ooh, it's a little bit too far from the power point, so we need a cable extension. So sorry about that. As I mentioned just now, the cables, one of it has white stripes on it. That is actually the negative one. Seems like not the same as what I've learned on college days, but as you can see, when I turn the main power on, it turns on, right? So to turn on the power governor to be operative, even though it has, as indicated here, the power has gone in, 5 volts has gone into the motor governor, but without pressing this, turning it on, it will not give any power out of this motor governor to our target, which is the locomotive. So when we turn it on, it's supposed to be a green, there you go, a green LED there. So that shows that this is operating. But before we connect the locomotive into this power governor, I would like to just try to see how much power it gives out of this power governor by means of using a voltmeter or a multimeter, right? So see, we're just going to slot this the probes on this multimeter into this power governor like so, and then we're going to turn on the power and see whether this indication, the numbers here, will match the numbers on the multimeter. Let's go. Turn it on. Okay, so when I turn it to 5005, the voltmeter shows 1.5 volts. Okay, when I turn it to 10, it shows over here 2.85 volts. And then when I turn it to, I think the maximum on this is 100, I guess. Let's go 50, half of the capacity that it can gives out. So the rating is 3.94, let's say 4 volts. So let's go all the way 100. Okay, that's the maximum, and it gives out, yeah, as expected, 4.8 volts, which is kind of near or close to the maximum volts, the DC volt that is written on this adapter, which is 5 volts. Over here it gives out 4.8, so there's a bit of a tolerance there, probably the resistance inside this motor governor. Alright, now we are going to tune this down to 0, turn it off, and we're going to connect the locomotive into this motor governor. Take out the probes of the multimeter, set it aside. So we need to connect the locomotive to the motor governor by connecting these wires to the locomotive. Okay, let's see where does the positive wires goes. So you can see that's the plus symbol there, and on the other side is the minus. So the minus, since we are just going to trial this, I'm just going to slip this wire right there, just making sure that it fits and not going loose, and the other side for the positive right there. Okay, that looks firm, okay, right. Oops, just have to slot this in even deeper. Okay, that's much better. So the negative cable, I have to switch it off first, right? Switch it off. So the negative, which is the solid orange, goes to the negative out over there. And the other one is the positive wire that goes to the out plus there. Make sure that we screw in the nuts on this motor governor firmly so that it won't go loose, right? Right, so let's put this properly so that everybody can see. Maybe I should put some weight on this cable so that we can see clearly. Okay, now the moment of truth, right? We'll switch on the DC power adapter first. There comes the power, and we have to switch it on. Okay, the green LED doesn't light up. I think because this is totally 0, we have to crank it up a bit, like 10 or 9 or 10, and then switch it on. No. So sorry about that. Actually, I got all of it wired correctly. It's just that I got too nervous to crank this meter up, the adjuster over here. So actually, when we start to give it 26 over here, you can see it starts to move. The wheel starts to move, but in a very strange way. As you can see, it's like, it's not like smoothly, right? If we crank it up, so that is the cruising speed that I would like the train to move, but it is not moving smoothly. If we crank it up, that's too fast. That is the ideal cruising speed that I would love the train to move, but it's not moving smoothly. Okay, maybe if I switch to using the 12 volts one, Will it make a difference? Let's see. I'm gonna try to change the 12 to the 5. Okay, just now we were using the 5 volts power adapter and it doesn't give a smooth movement to the motor. But now we have switched to the 12 volts over here, and let's give it a try. Switch on the main power. There's the digital indicator switched on. So let's turn this on and crank it up to 10. Yes, look at that. Okay, that's a 10. So if I put it at 9, that would be a very nice speed that the train should move when it is near the station, right? It's docking or it's starting to move. And let's crank it up. Okay, that is supposed to be the good speed when it leaves the station. And this should be the maximum speed, right? So as you can see, it's 14 over here. So what I don't recommend you guys to go is to go the whole 100% over here, because as I've told you, the motor can only cope up with maximum 5 volts, while this adapter is giving up 12 volts. So if you put it 100% over here, you will be delivering 12 volt DC directly to the motor, and it has a risk of burning it. So we're going to use this 14 as the maximum speed, or maybe we can try a little bit to find the maximum. So you can see the reading is 20 over here, while the motor is, I guess that's the maximum speed that the train should go. If it goes any faster, it's going to beat the Shinkansen train from Japan. So that's the maximum. Alright, so we have concluded that we should use the 12 volts DC adapter, and the 5 is not going to give a smooth movement to the motor. So, yeah, for those of you who has just tuned into this playlist, you've missed part 1, but you can surely come back to the playlist and watch it, because now you might ask, if I got these wires going to the locomotive, how will I power the locomotive on the tracks with these wires on, right? It's not practical, it doesn't look realistic. I have plans for that, and that would be shown in the next episode of this playlist, the locomotion. Right, so with that, we have a conclusion today, and to learn more about this and for me to explore and to share with you the experience, we're going to do a next part of it, part 3. So I will definitely see you in the next video. Good night.